Welcome back, learners. So today we will finalize the entire column design, and this will be the last lecture on the design of the columns. In the next lecture, so let us make the column grouping based on the column dimension and as well as the column reinforcement and the stirrup spacing. So then later, so we will give the reinforcement details along with the footings. So there should be a way to give that reinforcement details to the contractor, and then finally we have to make the positions of the columns as well as the footings together in the AutoCAD. That completes the column design. Then we will move up to the design of the beams. Okay, so we have completed this many number of columns. So now let us move on to the next column, that is column number 13. Okay, the column number, let us start from column number 67. Okay, column number 1. So when I open the column number 1, right, yes, so the column number 1, so the corresponding value of this is 521 and 48, 521 and 48. So this will be 521. Okay, so this will be 521, 521, and the corresponding this is 521 and the corresponding moment is 48. So according to this, the column dimension is 230 by 460. Okay, and I'm going to maintain the grade of concrete 25. I'm going to maintain D dash as 40. So this is 0.09. So this will be 0.04 and this will be 0.20. Okay, so 0.20, that means I'm supposed to check 0.1 chart 0.1, and the corresponding values is 0.20 and 0.04. okay, so 0.20 and you have 0.20 and you have 0.04 here. That comes out to be somewhere 0.14%. okay, comes out to be 0.14%. so when it is 0.14%, it is 3.5. I'm going to maintain 3.5. so this will be the footing, the total reinforcement. I'm going to maintain 16 mm dia bars. So this will be the one. So this is the total number of bars required. I'll make it to 20. So therefore this I can make it into the green color because no issues with this column. Similarly, I'm going to maintain the 10 mm spacing here. So anyhow, this will be same. So I'm going to maintain 200 mm center to center. Okay, yes. So this is about my column number 1. This is the column number 1. So after column number 1, the next that I can go is column number 2. So the column number 2, I have 1036 and 22. Okay, so column number 2, so it is 1036. okay, 1036 and it is 1036 and 22. okay, it is 22. so I'm going to maintain 40 mm only. So 25, definitely we cannot go for 230 by 460 because it is going to be the higher value. So therefore let us maintain 460 by 460, and I'm going to maintain the ratio as 0.01, and I'm going to make 0.01%, and axial load PU by FCK BD is 0.20%. so let us take 0.20 and 0.01, 0.20 and 0.01, it will come in 0.14%. okay, so I can maintain 0.14% here again. So 0.14 means definitely it will be 3.5. I'm going to maintain 3.5% only. So this will be the total area of steel, 116 mm, one area of the steel. So I'm going to get, so let us make the 20 mm dia bars. So therefore I am going to get 1 second, it is 0.14 means 3.5%, 16, it is not 201, if I make it 20, so it is 314. Okay, yes, the axial load on the column is heavy, right? 1036 is the axial load on the column. Okay, so 1036 is axial load on the column. So what we can do is the only option that what I can do is I can increase my column dimension, okay, to 460. 460 is already existing, so it is a heavy loaded column. Okay, so heavy loaded column. So let us keep 24 so that we can change it later. So let us keep 24 and 10. So definitely this anyhow I'm going to maintain, and I'm going to maintain 300 mm center to center. So this we are supposed to change. Let us make it to the red color. Okay, yes, so that is this column. Then next you have column 3, that is 518 and 55. 518 and 55. So it is column 3. Okay, column 3, it is 518 and 55. So this will be 25. This, what is the dimension it is having? The actual dimension is 230 by 460. 230 460. So 40 mm. So 0.09, 0.05, 0.20, 0.05 and 0.20, 0.05, yeah, which comes out to be again 0.14%. So it is 0.14, and this will be the percentage of steel. So I'm going to maintain 3.5. So when I do that, this is the area. I'm going to maintain 16 mm dia bars. So this will be that of one area. So 18 bars, I can give 20. So this will be 10. So same here, I'm going to maintain 200 mm lateral spacing. So no issues, I can make it to green color, right? Yes. So the next, this is, that is column number 3. Next you have column number 4. It is 475 and 85. 475 and 85, right? 475 and 85. So column number 4. 25 is the grade of concrete. 230 460. As per this, it is 230 460 only. 230 460, right? Yes. So 40 is the space, that is the D dash, that is effective cover. So therefore the D dash by D is this value. So 0.07 and 0.18. So 0.18, 0.07, which comes out to be 0.12%. Okay, I can have 0.12%. So the percentage of steel will be 3%. I'm going to maintain 3% only. So this is the total area. I'm going to maintain 16 mm diameter bar. This is the area of the one rod. So these are the total number of rods required to me, that is 16. Anyhow here it will be 10 as usual, maintain. So this will be 200 mm center to center spacing. Let us give it in green color, no issues. Okay, again the next you have is column number 5. So column number 5, you have 903 and 70. Okay, you have column number 5, it is 903 and 70. Okay, so 25. So actually it is 230 by 460. If you do that, definitely it won't work. Let us try it. 0.09, it is 0.06. This will be 0.34. So therefore even I'm supposed to make this as 460 only. Okay, so when I make that, it is 0.17, 0.17 and 0.03, 0.17 and 0.03, which comes out to be 0.12% now. Okay, I can go to 0.12%. right? Yes, when I go to 0.12%, so this will be the corresponding steel value. I'm going to maintain 3. This is the area of the steel. Okay, going to maintain 20 mm diameter rods. So this will be the total area of one rod. So I'm going to get 20 mm numbers. Okay, and I'm going, this is column number 5. I'll make it in the red color because I'm supposed to change it. So 10 mm stirrups. So this if I maintain, so I'm going to maintain 300 mm center to center. Right, I have to make it red color. Yes, that is column number 5. Then next you have column number 6. It is 646 and 53. 646 and 53. It is 646 and 63. Okay, so according to this, its dimension, if I see, it is again 230 by 460 only. Let us see column number 6, 25, 230, 460. So this will be 40. When I do that, 0.05, it is 0.24. Okay, it is 0.24. Right, so 0.24 is also, it's a very high value. If you want, let us try 0.24 and 0.05, 0.24 and comes out to be 0.05, which comes out to be 0.18%. You know, it is 0.18%, which is a higher value. When you calculate, it comes out to be 4.5. So therefore, let us make this also as 460 only. Right, so therefore when I do that, it is 0.12 and 0.03, 0.12 and 0.03, 0.12, 0.03, which comes out to be 0.08%. Okay, so then it becomes 0.08, sorry, yeah, 0.08. So therefore it comes out to be 2%. I can have the total area as this much. I can have 16 mm diameter bar. It is of 1 bar. So you will get the total. If I make it 20, then you will get 14 number bars. Anyhow 10. So it is 300 mm center to center. So therefore this also I am supposed to change. Let us make it to the red color. Okay, yes. Then next you have column 7. Okay, so column 7, I have 631 and 36. Column 7, 631 and 36. And what is its corresponding dimension? It is 230 by 300. They have given 631 and 36. So 230 by 300. Let us see column 7, 25, 230, 300, 40, 0.09. So 0.07 is mu. 0.37, again it is higher value, so therefore let us make it to 230 by 460 mm. So then it becomes 0.24. Still 0.24 is a heavy value only. So therefore this also let us make it to 460. Okay, so then it becomes 0.12 and 0.01. It is almost 0.08 only. So therefore I can get 2%. So 2%. This will be the area. Going to maintain 20 mm. So you are going to get totally 14 numbers. So this anyhow 10. You have 300 mm center to center. Okay, yes, that is column number 7. The next you have is column number 8. So column number 8, 527 and 26. column number 8, 527, column number 8, 527 and 527 and 26, it is 230 by 300, it is 26, okay, it is 230, 300, 25, column number 8, 40, 0.13 and 0.05, okay, 0.13, 0.05, okay, 0.13 and 0.05. Yeah, 0.13, it is d dash by d, 0.05 and it is 0.31. So 0.13 means I can go to 0.15. 0.15 is there. In that 0.15 you have the value of 0.31. If you see, it is 0.31, it is very high value, so therefore we cannot do that. So I am supposed to make, let us make this as 300 by 300 column. If I make it as 0.23, then let us make this same as 230 and 460. Then it becomes 0.20 and 0.02. Okay, 0.20 and 0.02. Then comes out to be 0.1, 0.20 and 0.02, which comes out to be 0.14%. Okay, manageable, 0.14. So therefore you will get 3.5. I'm going to maintain 3.5. This will be that I'm going to maintain 20 mm dia bars. So 314, I'm going to get 11. I can provide 12. So 10 here. So I can maintain 200. Right. So this also I'm supposed to change. So this is this. Then next you have 10, 491 and 69. 491 and 69. Okay, 491. That is column number 10, 491, 69. Okay, so 491, 69, column number 10, 25, 230, 300, 40. So therefore your d dash by d will be this one. This is the mu by FCK BD square. It is this also it doesn't work, therefore let us make 230 by 460 only. So therefore 0.19, 0.06, 0.19 and you have 0.0246, which comes out to be 0.14%. Okay, so 0.14%, right, 0.14. So therefore when I do, it is 3.5. I'm going to maintain 3.5. So the total area will be this 20 mm diameter bar. One area I'm going to get totally 12 numbers and 10 mm dia stirrups. So this anyhow 200 mm center to center. That is column number 10. So finally we have 3 columns. So once this is done, so our design is done. In the next video, so we will do the grouping of columns. Okay, so once the grouping of column is done, then we are supposed to do the grouping of footings and columns together. Why we are supposed to do the grouping of footings and columns together is, usually along with the footing, so they are going to cast the first part of the column. In the site, when you are casting the footing, along with the footing they will provide the first part of the column, that is initial position of the column. Therefore we have to group in such a way that while giving the details to the contractor, he should know the footing number and for that footing number corresponding column number. So like that we are supposed to provide the details, so that we will see in the coming lectures. So let us finish this design today. We have column number 11. It is 442 and 47, 442 and 47. okay, 442, yes, 442 and 47. So 40 I'm going to maintain. So column number 11, 25, it is 230 by 300. So when you do that, it is 0.13, okay, it is 0.09 and it is 0.26. So again little bit higher. So therefore let us make 230 by 460 only. So therefore I am going to get 0.17 and 0.04. 0.17 and 0.04, which comes out to be 0.12%. Okay, so 0.12%. So this will be the value. So 3% only I am maintaining. So this will be the area, 20 mm dia bars, 314. So I am going to get 10 bars. I can provide 12. So here 10, 230, the least is 200 mm. Okay, yes, so that is your column 11. Then last we have two columns. So you can almost take the highest value of this column 12 and 13. I can make 1125. Column 12 and 13, I'll make it together. Okay, the number I can give 12 and 13 together I can make. Okay, so together I can make 12 and 13, and let us take the value as 1125. Let us take the value as 1125 and let us make the value of moment as 130. Let us make the value of moment as 130, and column dimension is 230 by 460. Okay, the column dimension is actually 230, 460, so 25, right? Yes, so if I am maintaining the 40 as the D dash, if I calculate it is 0.09, but you can see it is 0.11 and the actual load is 0.43. Definitely it will be very high. Therefore let us make it 460 by 460. When I do that, it is 0.05 and 0.21. Okay, 0.05, 0.21. So you can see 0.21 is here, 0.21. Okay, so 0.21, and you have 0.05, which comes out to be 0.16%. Okay, it is manageable. So therefore I can go to 0.16%. Okay, and this will be the percentage of steel. 4% I can able to manage in the site, so I'm going to maintain 4% only. So and the corresponding the percentage of steel is very high, right? If I maintain 20 mm dia, then definitely it will create a very huge value. 0.314, you can see it will create a 26 bars. So therefore let us give the 24 mm dia rods. So then it becomes 20. Okay, I can manage with this. And when I'm providing the reinforcement of for the stirrups 10 mm, so this will be, I am supposed to make 300 mm center to center, right? So this is how we are supposed to do the design of columns. Now our design of column is done. As I already told, in the next lecture, let us make the grouping of the columns first as per the reinforcement. Then let us make the grouping of columns and footing together. Thank you, learners.